In this problem, we're going to rewrite the equation negative 3 cosine x plus 4 sine x, which is called a linear combination, and we're going to rewrite it as a single cosine function with a new amplitude and a phase displacement. And so our goal is to find the new amplitude and the angle in which it's been shifted by. So I've started by graphing negative 3 cosine x, 4 sine x, and then the sum of the two. And so you can see right here is the negative 3 cosine x, the red is the 4 sine, and then the black function is the sum of the two together. And so you can see that the resulting sum is just another sinusoid. It does have a larger amplitude, and if we're talking about cosine, it's been shifted to the right a certain amount of degrees, or in this case, radians. And so in class, we learned in order to find the amplitude, we're going to use the amplitudes of cosine and sine. So since the amplitude for cosine is negative, that corresponds to the x value, and the amplitude for sine is positive, that corresponds to the y. So I'm going to draw my triangle in the second quadrant. My x side of the triangle will be negative 3, where my y will be a positive 4. And so my amplitude comes from the hypotenuse of this reference triangle I just drew. So I will take negative 3 squared plus 4 squared, and that will give me my amplitude squared. So I'll have 9 plus 16, and so we will end up getting an amplitude of 5. From here, to find the phase displacement, we need to look for the angle that would get us to this terminal side, and we call that angle D. And so to do that, I can take the tangent inverse of 4 over negative 3. And you'll want to make sure that you are in radian mode. We will take tangent inverse 4 divided by negative 3, and I end up getting negative 0.927 radians. Well, that's actually down in the fourth quadrant, which clearly we need to be in the second. And so to find this answer, I'm going to add 180 degrees, which I'm not going to add 180 degrees. I'm going to add pi since we are in radians. And I will do that to my entire answer that's already in my calculator. And we will end up getting about 2.214. That's a positive angle to get me into the second quadrant. Remember that when we're transforming trig functions, that on the inside it's the opposite of what you think. So this will be x minus 2.214. So this is my equation, and it should be equivalent to this linear combination here. So to verify that, I'm going to go ahead and turn off these first two graphs so we have a little less to look at. And I'm going to graph now my single cosine function, which is 5 cosine, I have an extra set of parentheses there, of x minus 2.214. And if we did this correctly, these two graphs should be the same exact graph. So you can see here's our original when we added the cosine and sine together. And now here you can see the pink graph is going right on top of the black function, so we know that they're the same.